Today we're looking at synthetic division, which is another way to divide polynomials. There are some definite pros and cons to it. The pros, I think, outweigh the cons. The pros are it's less work, you have to write less opportunity for confusion, for mistakes. Long division uses like multiplication and subtraction. Synthetic division uses addition, and I think there's a lot fewer mistakes when you're adding things than when you're subtracting with negative numbers. The one con to synthetic division is that you can only divide by first degree binomials. So it can only be a plain x and a number, a two-term binomial that's a first degree. Anything, if it's like dividing by x squared, you can't use synthetic division for that. Synthetic division uses the coefficients. So this is 1x to the third minus 1x squared minus 2x plus 8. We're looking at those numbers that are in front of each term. Just like with long division, you have to first check for missing terms. So if you're starting with x cubed, you have to make sure that you have x cubed, x squared, x, and then a number. Like in number 3, see how we skip from x cubed to x? That means there's a missing term there. So always look for missing terms first. Now you don't have to start with x cubed, but if you start with x cubed, then you need to have x squared and x and whatever. Here's how synthetic division looks. You start with the coefficients. 1x cubed, negative 1x squared, negative 2x, and 8. The division bar is kind of upside down. You need an L-shaped bar that has enough room for you to write, excuse me, a row of numbers underneath. If we're dividing by x minus 1, we're going to put a positive 1 outside the bar. So you always put the opposite of the number, or the number that would make the parentheses equal 0. That's the number that you put outside the synthetic division bar. Your first step is to drop the first number straight down. Now we're going to do a series of multiplication and addition. We're going to multiply 1 times 1. That gives us 1. Then we're going to add those two numbers together. Negative 1 and 1 is 0. That's the first cycle. So remember with long division we talked about do the first cycle and then start a new cycle. That's the first cycle. It's already done. Now we do 1 times 0 to get 0. Then we add to get negative 2. Multiply. 1 times negative 2 is negative 2. Add. 8 and negative 2 is 6. The last number is always your remainder. We're done with the division. Now we just have to interpret what this means. This thing is our answer. It's going to be 1x squared. Because we started with x cubed and we divided by x, we're going to decrease the exponent by 1. So this term is 1x squared. The next one is your x term. The next one is your plain number term, and then your remainder. So 1x squared plus 0x minus 2, and then 6 over what we originally divided by. Now, do we really need that term in our answer? No, we do not. Our answer is 1x squared, or just x squared, minus 2 plus 6 over x minus 1. Okay, let's do that again. Our coefficients are 1, 2, negative 6, negative 9. We do not have any missing terms to deal with. If we did have a missing term, we'd have to put a 0 in there in place of that term. We're dividing by x minus 2, so we need to put a positive 2 out front. This number is always the opposite of the number that you see in the parentheses. Drop your first number straight down. Multiply that number with these numbers. So 2 times 1 is 2. Then we add. 2 and 2 is 4. Multiply 8. Add 2. Multiply 4. Add negative 5. That is our remainder. We started with x cubed, so this first term is x squared, then x, then the number. So our answer is 1x squared plus 4x plus 2 minus our remainder of 5 over what we originally started with. The next one does have a missing term. There's a 0x squared. So we have 2x cubed, 0x squared, 12x, and negative 7. We're dividing by x plus 6, so we put a negative 6 out front. I want you to pause the video and try this one on your own. If you do start getting big numbers, don't worry. Sometimes with synthetic division, you get big numbers. Did you pause the video? I don't think you paused the video. You need to pause the video. Try this problem on your own. Like, seriously, pause the video. Pause it already. Come on, pause it. Like, I really wasn't joking. Pause it. Try it on your own. Be brave. Okay, here we go. Your first step is to drop the first number. Multiply. Negative 6 times 2 is negative 12. Add. Do you need to draw all the lines? No, you don't. You can get to the point where you just remember it's multiply, add, multiply, add, multiply, add. 0 and negative 12 is negative 12. Multiply negative 6 times negative 12. Sorry, that one requires me to do my calculator. That's 72. Add 12 and 72 is 84. Multiply. Are you glad that I gave you a hint that you might get large numbers? Negative 6 times 84 is negative 504. Add the negative 7. We have negative 511 as our remainder. Honestly, I have my calculator off to the side and I'm just doing like negative 6 times 2 equals plus 0 equals times negative 6 equals plus da, 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 da. Just if you have your calculator off to the side, you can do almost all of this in your calculator and not put a ton of thought into it. That sounds terrible that I'm saying that, but you know, it is what it is. We started with x cubed, we divided by x, so this first term is an x squared term, and then an x, and then a number, and then a remainder. So we have 2x squared minus 12x plus 84 minus 511 over x plus 6. There is a way to use synthetic division to evaluate functions. I did not put this on your assignment, and I don't think it's on the test either. I'm going to go through one example just to show you how cool this is, but you're not going to need to do this. So if you're fine with just doing the bare minimum, you can stop the video here and go work on your assignment. Setting up the synthetic division for evaluating is exactly the same. You still have to account for missing terms. This does not have any missing terms, so we set this up 5x cubed negative 1x squared 13x 29. With evaluating, you do not put the opposite in. If we're evaluating for x equals negative 3, we're going to put negative 3 right here. This is the same thing as doing 5 times negative 3 to the third minus negative 3 squared plus 13 times negative 3 plus 29. The thing is, when you evaluate polynomials with negative numbers, you have to use parentheses in your calculator, otherwise your calculator does order of operations incorrectly. With synthetic division, it takes that piece out of it, so you don't have to worry about the parentheses. Once you have this set up, it works exactly the same as with division. Negative 3 times 5 is negative 15. Add. Negative 3 times negative 16 is 48. Add. Negative 3 times 61 is negative 183. Add. The number that you get here is your answer. So f of negative 3 is negative 154. And let me grab my calculator. So if I do 5 parentheses, negative 3, close my parentheses to the third, minus, oops, I need to get out of my exponent, don't I? I thought I hit that button. Minus parentheses, -3, close my parentheses, squared, plus 13 times -3 plus 29. Calculator tells me that's -154, and that is exactly what synthetic division told us it also was. So you can use synthetic division as a way to evaluate functions when you want to plug a number into the function.